Hello kids, today we will learn about binary search. So, as you know, when we have data collected in an array, we in practical life also we have to search for things. We search for websites on Google, we search for files in our computer systems, we search for photos in our phones, we search for particular messages in our WhatsApp chats, right? So searching is a very important operation which we do being in this digital world, and the most popular search is, you know, and you do it every day, which is Google search. So a linear search is another one which we have in searching techniques. So linear search is very simple one. I'll just take a little bit of that also before I go into the binary search. So linear search is something where you have data stored in an array and you are simply you know, looking. Let's say you have to search for 7. So you will in a linear way or in a sequential way, you will go to each an element and see whether the element is equal to your search number or not. Then you go ahead, and then you keep on moving ahead until you find it. So let's say here you find that, and that is your output. Yes, the item is found at particular index or the position. So here in this case it is 0 1 2 3 4. Okay, so the item 7 is found at location 4 or index 4. Or if you don't find it, then you just let's say if your number was 17, which we have to find, and then you go from first to last element, and you don't find it, and you just say that the item is not found, right? Okay, is not found in the array. So this is a simple search, linear, in a linear way you do that, and it can happen irrespective of your array is sorted or not sorted. But this takes a lot of time. There is one more technique which you have in your syllabus of ICSE is binary search, and this search can happen on a sorted data. So this you have to remember that you have to sort your data first or sort your array first to imply or to implement binary search for that data collection data. So you have to have an array which should be sorted first. Okay, so let's say you have something like, say, 2 3 5 7 9 11. Let's say this is your array. Okay, now I'll take one more element in this, 30. Okay, so now let's say you have to search for 7. Let's do the first case first. Okay, let's say you have to search for element 7. So what happens in binary search? Binary means 2. Okay, so you have to divide the array in 2 parts, and you basically take the midpoint of the array and you see whether that midpoint is equal to your search element or not, and if it's not, then you do task accordingly. So since I'm taking the case 1 right now, which is I have to search for 7, and I see that the middle point is over here of this array, and my search number is equal to the element at the midpoint of this array. So I find this and I just end my search. It's found. Okay, but that will not be the case always. So let's see the case number 2 now. Let's say you have to find 11 in this array. Okay, so what will happen? So again I'll just quickly draw this array. Okay, now what will happen? I'll take the midpoint of this array, which is this index. A midpoint means you have to find that middle point, the mid index of the array, mid position of the array. Okay, so we'll do the calculations later, but just understand the logic first. So this is the midpoint. At midpoint of the array we have element 7. So your search element is 11, right? So you have to now, since this is an sorted array, so you compare whether your midpoint, which is at 7, is greater than or less than 11. Okay, you just see that scenario. Now here I see that 11 is more than 7, right? It's more than 7. So in a sorted array, in which part of the array 11 will fall? Will it fall in the right half or will it fall in the left half? Since this is an ascending order sorted array, of course 11 is more than 7, so it will fall in the right half. Okay, so now I don't have to go in this left half at all, so that saves my time. I only have to consider, for next iteration, I only have to consider the right half of the array. So you are cutting your time down to half now, right? So now my search array has become only this one. This is my search array, the new part now. Okay, again I will do the same thing. I will take the midpoint of this. My midpoint of this is, fortunately it's 11 only. So at midpoint of this right half of the array in which my element lies logically, it is midpoint is 11, and I find that 11 is equal to my search element as well. So my search is done. Okay, now let's say the third case, if I say my element to be searched is, let's say 2. Okay, so what will I do? For 2 I'll have to so I'll just do this, start with the same thing. I have my array here, quickly I'll just draw. Okay, I'll go to the midpoint. It's not my search element, and I see that 2 is less than 7, so I will go in this half. Okay, I'll go in this half now. So my left half is considered, this is not to be considered because logically it will fall in the left half only because it's less than 7 and it is my sorted array. So I'll go here, then I again find the midpoint of this left half, it's 3, so it is not equal to 2, it's not equal to my search element. Then I compare again whether 2 is less than or greater than 3. Now I see that 2 is less than 3, so now again I have to go towards the right side, right? Now this is, in this array my midpoint was 3, now my search element 2 is less than 3, which means that it will fall in the left half of the array. Now my array to be searched is only this one, right? So now again at this is just one element, and it is the midpoint itself. So now I see that 2 is equal to 2, which is my search element. So my arrays, my search is over, and I find the element at this index. Okay, so this is how you go ahead with your binary search. So it's basically, I'll just revise. So you have to take the midpoint first. Okay, then when you have to see that the search element is equal to that midpoint element, or it is in the right half or in the left half. Accordingly, you take that half again as the new search array, and again you take the midpoint, again you compare your search element with the midpoint. If it's there, then it's found, otherwise you just again compare it, it's less than or more than that, and then accordingly you take the right of the half of the left half, and that's how you go on. So you see that the binary search actually is halving your time every time to search the element. So only condition is that you have to use a sorted array for this. In the next video I'll tell you the code about it.